So moving on, I wanted to cover a bit on the high level architecture of the platform. I was seeing a lot of videos. I kind of pulled this image out from there. I'm going to reference it in the description too. So basically the way it kind of works is there are two things, two separate boxes, the blue and the green, you can see. The first one is your Databricks cloud account. So all your stuff hosted on the Databricks cloud. So basically this platform you see is kind of being hosted on the Databricks cloud. It's not on the AWS yet. It's separate. So it contains your application and then the notebooks and the metadata for the clusters, the jobs, and etc. So no actual data manipulation or execution of code happens here. Okay, so this is just a platform where everything resides, the metadata resides, and then you log on to this platform. Everything is kind of covered using like the single sign-on feature, and then the next concept comes in is like your AWS account, because Databricks being a managed service, the whole application manages itself once you connect it with the API keys in your AWS account. So the next thing it does, it connects to your AWS account, and that's where the magic lies. As this being the managed service, it executes this code of your notebook into clusters. So as I showed here, so once you click on clusters, you create a cluster there, then it's going to pop up virtual machines inside of the virtual EC2 instances inside of AWS. Then you have a clusters in place, right? And then once you go into developing or deploying your job, all the Python code is kind of being executed into that cluster you mentioned. So nothing happens inside of the blue box. All your data all your data transformation execution kind of happens here inside of the cluster. And the best part is the data also resides in AWS. It's not residing under Databricks. So it's all under your controls. So that's the idea behind creating Databricks. All of it is under our control, our AWS account. And then the data is stored on the AWS blob storage, AWS S3. And then this is kind of most of it, like how things are inside of a Databricks platform. It's like a managed service, very easy to use, and it kind of takes a lot of the overhead of building cluster, deploying clusters, managing everything, takes away from you, and it's just let you focus on your data and the problems related to your data. All right, as in for the next step for this video, let's look at actually developing inside of Databricks environment. So for that, there are going to be two parts in this video. I'm going to first quickly take you through like one of the quick start notebooks where we start a cluster and run a few jobs. So let's quickly do that. So in this video, let's try to create a cluster now, because I don't have it I don't have it right now in place. So if there are like multiple ways to do it. So you can click through here, because then basically what happens through Databricks architecture, then once there's a cluster in place, you can just attach to a cluster and run your jobs there. So very simple. That's the best part. So let's quickly go to the cluster tab and try to create a small cluster, because I'm kind of using the free tier of AWS. So I'm going to say YouTube Qt, and then the cluster would be like a standard single node or high concurrency. As this would be a small job, I would prefer to get a single node right now, because instead of going for like multiple nodes, multiple cluster with high concurrency, rather let's not do that, because that's not required. But that's the idea, that's the level of abstraction you get. You just need to decide on the type of cluster you want, and then it's just going to create. So for now, for me, single node, because this is the best use case for a development environment. But once you want it to be executed across a huge data set, then it makes sense to use it. So in terms of pool, it would be none. Let's quickly look what pools is. Pools keep a defined number of ready instances. I don't want that, because I think that's more of a team working together if they want a cluster in place all the time, if some multiple people are using, because yeah, that's not the case right now, because running a cluster would take some time. In terms of the cluster, in terms of the machine, you need to select the node type. I will try to go for a basic one, just to avoid the cost. But you can like select the node type based on your requirement. The idea for me would be to get a very small instance, like M4 large, like a general purpose instance, because I'm just going to import the data and do a few transformations. Let's look at what are the options. I'm going to go for a general purpose instance, and an M4 large definitely makes sense to use. Yeah, let's quickly, I don't want like a GPU accelerator, I'm not building a model, so but yeah, it kind of allows based on the based on what you have in place for AWS, you kind of choose the instance. So for me it would be an M4 large, because the idea is you're gonna use it for parallel computing anyways. Cool. Then there are advanced options, then you can select a few more things. Let's not go through that right now, but they're like an IAM pass through and like a few more things. Let's not go through that. And then you can SSH into it like using this. But yeah, let's just skip this one and start creating a cluster. It's as easy as creating on the button, create cluster. So let's just wait for it to create one, then we can start working on the development environment. All right, it's working on creating one, so let's wait for a bit. Now our instance is up and running. It's a single node, as I said before. So let's try to quickly see a few more things. So once you create a cluster, it shows the type of instance, the runtime, everything's kind of figured out already. You can see the notebooks attached to it. Then you can see libraries being installed. It's very easy to install libraries through here. And then event log is just showing all the events. There's Spark UI in place. All the Spark related things in one place. Then some driver logs, metrics. Through a cluster, before I move on to creating a notebook and attaching a notebook, one more thing I discovered, that you are not only limited to using a Databricks notebooks, so you can use your own environment, any environment, like not about environment, any IDE, sorry. So you could use any IDE like Visual Studio Code or like specific any Jupyter notebook as well, PyCharm, etc. So I leave a link to this, but yeah, I'm not going to cover this. But yeah, you can, if you're comfortable with Visual Studio, you can just definitely connect to it directly to the cluster. But from the way I see it, for a data science friendly team, this is already a very good and lucrative option. So moving back, let's go to our workspace. Let's quickly see the quick start notebook for first, and then I'm gonna cover a few more things like a custom jobs where I kind of import a different set of data. So already you can see you can attach it to a cluster. So 2 cores, 1 machine, yeah, whatever. And then moving on, once you attach, you can start running your notebook very easily. So yeah, so let's just hop on ahead and try running the notebook. Similarly, it's very similar. So in this case, the way to create a table, it's very easy in this case, because you just need to import the data and basically reference it to that data existing in the database. So basically what happens is this data is kind of existing in one of the buckets there in S3, and then it refers to it and creates a table there. So let's try to do that. So it's running the command. It's going to take a few seconds. All right, it's doing a smart job to, oh, voila. So it's already has a table in place. So it does a Spark job behind the scenes and create the data table inside of your Databricks workspace. So you can, if I go back, if I go to the data tab, I can already see the data table in place. And this is a NoSQL database, but it's actually based on the S3 storage inside of my AWS account. Cool. So if you'll see the data, it's going to give a schema, and then it's going to give a sample data in place. So it's just giving details about this sample data is containing details about different diamonds and the price around it. So you can see I know some things about the clarity is like SVS, something like that. This like a clarity, and it kind of The price is actually varied upon the clarity itself. It's not only the caret in the diamond is actually a size. But anyhow, let's not go into the deep for this, but let's try to complete our quick start notebook anyways. So moving back to the notebook, the best part for about the notebooks in Databricks, you can run directly SQL, Python, and Spark jobs just in the cell itself. No need for any wrapper or any library for it. So if you run, so this is not specifically like a Jupyter notebook, but it's like more of a Databricks notebook, which is altered to their use case. So for a data analytics person, they don't have to import any other library like scikit-G2. They just need to run the SQL codes. So that's why it makes sense. In the next step, it's the same thing happening, but it's just trying to do it through Python. So if I execute it, it's gonna pull the data through Spark, and then it saves it in the Delta Lake. That's the second job, which is the few jobs which are executing in parallel to move the data as a CSV from the dataset to here. So let's just wait. So the best part of all of this is that no configuration of Spark or pulling the data through data engines not all of those complexities are included. It's just that very easy to get the data onboarded into the notebook, then use simple SQL to understand the data. So that's the best part. Anywho, I'm gonna do a few more things. I'm gonna show a few more things. Let's skip the one above it. But yeah, after you have the data in place, you can, very similar to Jupyter Notebook, create a few small charts, and through this, through the Databricks notebooks, you don't have to import any libraries, even though people must be a lot of you people must be comfortable with that. But yeah, so basically once you execute a select statement, it pulls out the data, right? So if you can see down below, there is option to show the data in the table. So for example, let's execute this again. So this is going to execute the data using a Spark job behind the scenes, and then shows me the data. Then I have another option of displaying it as a chart. I think it's very user friendly to business analysts or data scientists to just use this. Even the data engineers like me, so no importing of libraries, things are in place already, so I can show it like this. Before moving forward, I wanted to cover a few more concepts around this the Databricks notebooks. So the best part is like once you create a notebook which has a few which is not like totally a development notebook, which has a refined code, then you can just click on schedule and schedule your jobs by scheduling this notebook. Another part is you can add in comments, because this is supposed to be a co-sharing workspace, like a sharing workspace with other data scientists or engineers. I go ahead and try to add comments. So if I can just select a piece of code and try to add a comment there. Yep. So very simple. Then there is like something around experiment, which I haven't covered yet, but yeah, it's around building machine learning models, more for a data scientist track. But yeah, you can just go there and do experiments on the data and build the experiments from here. Last but not the least, another part is the revision. I think that's a very good thing in place, because multiple people are working, similarly to like a Git, where you can see how people have made changes. So you can always hop on to see this, like what people have updated, and see the revisions. So pretty straightforward for people to use. Apart from that, all the other content is very similar to like a Jupyter notebook. So anyways, let's not get into that. You can also create a dashboard using the same notebook as well. I wanted to introduce that too.